Thank you for joining us today in our session on modernizing backup and moving off of tape. Today we're joined by Jesse Martinick from Southern Oregon University, and also Peter Balazides, who's a product manager here at AWS for Storage Gateway. I'm David Green. I'm an enterprise solutions architect here at AWS. Today we're going to talk about basically backup and how tape is used in the environment today and how we can migrate that to the AWS cloud without much change on the on-site setup. We're going to talk about the storage solutions that we have on AWS that you can use as a backup target. And also, Peter's going to show a demo of migrating from disk or from tape to AWS in less than 10 minutes. So it's super easy. And that's all fine with AWS talking to you and telling you what's possible. But Jesse's actually going to show how Southern Oregon University did this in production for real. So today we're here to talk about tape. And tape's been used with computer systems for about 65 years, with UNIVAC being one of the first ones. And well, it's not actually this kind of tape. It's really one of these. This is LTO. LTO's been out for about since 2000 with LTO version 1. And it's really become one of the standards for tape-based backup for on-prem. So tape, who likes tape? Well, I'm a converted tape user. I grew up watching awesome spy movies and cool agency movies with these robots flying around and tapes, and I thought it was the awesomest thing ever. I thought maybe one day I can build something like this in my career. And I was able to. I built out several enterprise-scale, multi-petabyte with thousands of LTO tape systems, and I thought it was pretty awesome. I achieved my childhood goals of building out cool systems with robots, and it was fun. As these tapes got filled with data, however, we had to take tapes out of the library and vault them to make space for new tapes. And it was easy at first, right? We moved some tapes out, put them in the vault, hopefully keep it organized so you know where they are, you can find them later for the restores. Life's easy. And then quickly, this became my life. Scaling out vaulting systems, having data center floor space for libraries, and what I thought was once super awesome ended up being not as fun as I thought it would be. So let's take a step back. Like, what do people want out of tape backups, and why is tape used? So we talk to lots of customers, and we see different use cases. Some customers want to write the tape to keep it on-prem to either protect against perhaps accidental deletion of data on their storage systems, or to also maybe write older content to tape to keep the expensive disk used for online active content. Some other customers use tape for geographic redundancy. They write the tape, they copy the tape data off-site, maybe to a different geographic region, and then when they need tape restores, they execute a job, tape gets put on a truck, drives it back in. And there's multiple cases. And when people think about tape, they typically think it's pretty inexpensive. But typically the cost people think about is the actual tape cartridge cost, but not the additional cost that may come with maintenance or library. And there's some costs involved with even licensing. So perhaps you buy a tape library and you can't use all your slots unless you license what you have sitting in front of you. You can't even use them. In some cases, there may be costs if you have multiple tape copies going off-site and managing that. But one of the biggest things, not only financially, but just from an operational standpoint, I think is often overlooked, is tape lifecycle management and cost sharing. So like I mentioned, LTO 1 came out in the year 2000. And now we just heard about the announcement of LTO 8 in the Q4 of 2017 here. And what happens as you write data on all these versions, and you ideally want to keep data modern, right? So we see customers maybe wait a few versions before migrating over, but you essentially waste capacity of your library and as you do these transfer jobs. And it's not easily attainable if you have hundreds or thousands of tapes. So we develop our products based on feedback, and this is something that we heard often from the field. So we really wanted to make things easier for customers. So with AWS Storage Gateway, customers only have to manage really two things. So one thing is backup applications, which you were already managing in the beginning. And what's great with Storage Gateway is you can use your existing backup applications and write to the Storage Gateway because it appears as an LTO library and LTO drives, and your application doesn't know any different. Other things for management may be the virtual hardware that you're running on site, because you download the storage gateway as a virtual appliance. So you're running that hypervisor, so whether it's VMware or Hyper-V or whatnot. And then perhaps managing storage services. So if you're writing to S3, you might want to have that automatically lifecycle down to Glacier or something similar. And at AWS, we provide a ton of building blocks across the entire ecosystem. And with storage, today we're going to focus on the AWS Storage Gateway family. And specifically, as a target on the cloud, we're looking at S3 and Glacier. So why are customers switching to us? Like I mentioned, you can use the same backup application, and the backup application doesn't know any different. We see customers also write data to on-premises tape and also write data to the virtual library that sends it to S3 or Glacier in a region that you choose. S3 and Glacier have 11 nines of durability, so your data is ridiculously durable, and it's very safe. And S3 has been general availability for over 11 years now, so we have experience running at scale. And it's very secure. You can easily audit who's accessing data and set policies around that. And one of the biggest things for migrating to the cloud, not only for storage gateway, but cloud in general, is it allows your business to really focus on your core competency. Because most likely your business isn't about managing tapes and making sure everything's running. It's really delivering product for customers or educating students, and just really focus on what your business does. So with its cloud, you pay as you grow. So let's look at the old world. In the old world, let's say you bought some storage. It's a petabyte of raw space. Once you RAID and format, let's say you get about from 1 petabyte down to about 800 terabytes. You don't want to allocate 100% usable storage out to your application. So let's say you allocate out for available use 600 terabytes. But what if your application is only using 400 terabytes today? So you're essentially wasting money on capacity. You have power and cooling and everything associated with that. And what's great with AWS storage services in the new world here is you only pay for what's used. So as you add data, you pay for what you add. And the other way is true too. As you delete data, you pay less. And it's just what makes sense and what's fair. With S3, you can choose your types of storage that you land on. So there's 3 main offerings for the object store. There's S3 Standard, S3 Infrequent Access, and Glacier. With S3 Standard, it's really designed for heavy read, heavy write, a lot of I/O, like it's your hot storage. S3 or Amazon Glacier on the right side there is really designed for archive. And it's 0.4 of a cent per gig per month, so it's very inexpensive for archive. And right in the middle there is S3 Infrequent Access, which is a nice warm area in the middle. It has the same I/O performance characteristics as S3 Standard, but it's priced in a way that's really designed for online storage, but it's really not for heavy I/O. And you can move data between these easily. So now we talked about what storage is on the cloud. How do you actually move data there from your systems? The most simple way would be something like S3 Sync. So S3 Sync is almost like rsync. You run the command, sync, you source, your source path, and destination could be the S3 bucket. And it leverages things such as S3 multi-part upload, encryption in flight, encryption at rest, all this good stuff. There's third-party cloud connectors that act as backup agents, and they can natively talk to our storage services, whether it's S3 or Glacier. And of course, we're here to talk about Storage Gateway, and the Storage Gateway we're going to go into later on here in the session. For the backup products with cloud connectors, there's many out there. So Commvault, Cloudberry, NetApp has offerings, and there's several you can choose from. And in some cases, it may be even the same backup vendor that you use today for your on-prem backups. But with Storage Gateway, it comes in 3 flavors. It comes in file, volumes, and tape VTL. So with files, it's really cool because you export a file system from on-prem using common file access semantics, and the files that you drag and drop onto the gateway appear on S3 as a one-to-one mapping to an object. So what that means is you can write data to a filer on-prem that goes to S3, then access that in the cloud without any workarounds there. Volume mode, export to iSCSI block volume. And snapshots of that block volume can go to EBS snapshots and then be rehydrated in EC2 for use on the cloud. And with tape mode, we export a virtual tape library and LTO drives over iSCSI. And this supports Amazon CloudWatch, CloudTrail, IAM, and KMS for encryption. And to provide a deeper look, I'm going to hand off to Peter.
OK. Thanks, David. So as David mentioned, there are 3 flavors of storage gateway. Why are there 3 flavors? Well, there are 3 flavors because you back up your data in different ways. If you're backing up individual files, you can deploy a file gateway, which connects via NFS to your backup server. Those files appear as objects in an S3 bucket that you own. If you're backing up block-based storage or volumes, you can deploy a volume gateway, and those volumes are stored in S3. And then you can also take periodic snapshots in EBS of those volumes to restore from. If you're writing to physical media, to tapes today, then you can drop in a tape gateway and start writing to virtual tapes, which are stored in AWS, stored in S3, and then you can tier those tapes to Glacier for the lowest AWS storage costs. We have customers today backing up files through File Gateway. Again, File Gateway connects through industry standards, through NFS. Those files are uploaded as objects in a bucket that you own and that you manage in S3. And because you own and manage that bucket, you can apply lifecycle policies so that you can tier that data to S3 and frequent access and to Glacier. File metadata is preserved as object metadata. And there's a one-to-one mapping of those files to those objects. You can also apply versioning and cross-region replication. And because it's all up in AWS, you can restore from that by deploying a new gateway in EC2 and restoring from those files. An example of a customer that has deployed this solution is SAP. SAP was looking for an innovative way to back up their adaptive server enterprise databases, formerly known as Sybase, and they zeroed in on File Gateway. So they connected their File Gateway to their backup server. The adaptive server enterprises databases are dumped into the File Gateway on premises. File Gateway manages moving those databases to Storage Gateway and to AWS. And that's how they're backing up to the cloud. Another neat thing about this implementation is that they've also added a CloudWatch event. So with that CloudWatch event, they're getting an SMS message letting them know when that upload has completed. So they're able to manage metrics, capture metrics, and understand what their RPO is for uploading that data to AWS. Another interesting point is that SAP has recently authored a white paper where they are recommending backing up their ASC to the cloud using File Gateway as their reference architecture. So that's a real-world customer example using File Gateway. Now again, if you're backing up using physical tapes, you can drop in a tape gateway. Tape gateway is a virtual appliance that you can deploy on premises or in EC2. And what it does is it connects to your backup server using iSCSI, and it presents a tape drive and a media changer. And the virtual tape library is all in AWS. You can create virtual tapes at the click of a button, and I'll actually demonstrate that during the demonstration. Those tapes reside in S3, and then again, you can tier those tapes to Glacier for the lowest cost storage. Data is compressed both in transit and at rest. There's also a local cache for your most frequently accessed data, so that you can access that data really quickly. And the data is secure and encrypted. And you can actually have an unlimited number of tapes, which is great. You can have up to 1,500 tapes which are immediately available in the tape library. And then once you archive those tapes, you can have an unlimited number of tapes. Now, I understand that you may have made an investment and a commitment to some of these leading enterprise backup applications, whether it's Veeam's backup and replication, Veritas's Net Backup and Backup Exec, Commvault, EMC's Networker, Hewlett-Packard's Data Protector, ArcServe, Microsoft's DPM. And if you have made a commitment and an investment in one of these backup applications, that's great, because you can continue to use these same backup applications with Tape Gateway. Tape Gateway, again, presents itself as a tape library, and these applications see it as just another tape library. The only difference is, rather than writing to real tapes, you're writing to virtual tapes, and those tapes are stored in AWS. So everybody wants to save money. And many customers look at what's something like this going to cost? Well, Sony's New Media Solutions came across this very dilemma. And let me tell you a little bit about Sony New Media Solutions. This is the division of Sony that's responsible for disseminating content from their movie studios, from their music labels, from their video game labels, and from broadcasters. And not only are they responsible for disseminating and distributing that content, but they're also responsible for archiving that content. And they were archiving it on physical tape. And they came to a point in time where they needed to replace that tape infrastructure. They were writing they had about 20 petabytes of data, and they were writing and adding a petabyte every quarter. So a good amount of data. Now, I'd like for you to focus on the dark blue line. The dark blue line represents their on-premises costs, and you can see the spikes punctuated by those pink dots. Those are the points in time where they had to replace that physical tape infrastructure, spending millions of dollars on that. And you can see that in that first year, there's a very high cost where there's that capital expenditure. Then the costs go down because they've already spent that money. Now they're just buying some tapes and some administrative costs. And then it dips below the yellow line. Now the yellow line is the cost of storing this data, the same amount of data, in Glacier. And you can see in one point it even dips a little bit below. But then in the fifth year, again, they need to replace that physical infrastructure. And then it spikes up again. So using this analysis, and it's a really nice analysis, they estimated that they would save over 5 years a little over $2.2 million. Over 7 years, they would save about $5.5 million. The other interesting point here, aside from the cost savings, from my point of view, is the predictability. You can see with the yellow line, the Glacier cost, it's very predictable. You know what you're going to be spending year after year, as long as you know how much data you're writing. Whereas with the physical tape infrastructure, it could break down, you might need to replace it, et cetera. Now, you might be thinking, okay, so Sony's a big company. I work at a smaller company. What about for a smaller company? Well, I was recently working with a smaller company. This was a regional utility company. And this particular company was writing about 100 terabytes of data every month. And on average, they were doing 1 tape retrieval, and they were keeping their data for 1 year. On the left-hand side, you can see the blue, and that's the cost for storing the data using Tape Gateway in AWS. So there's that bar associated with archiving those tapes in Glacier. There's a nominal fee for writing data via the gateway, which caps out at $125 a month. There's the data transfer out for 1 tape. And there's an admin, a little bit of an admin time to manage this operation. Compare and contrast that with the right-hand side, the pink side, which is what their actual costs are with the physical tape infrastructure. So you can see there's a sizable amount of storage or costs associated with offsite storage. There's the tape media cost, so they're buying tapes every month. There's the cost of the robotic tape library, which, again, is spread out over the life of the library. There's the tape library maintenance, which might be an annual contract. And then there's admin time. You can see the admin time portion here is a lot larger. And this might not be the case for everybody, but in this one particular example, this customer had an admin who was actually driving tapes between 2 different sites and their data center every single day. And I think we can all agree that that person can have a little bit more useful things to do than driving tapes around. Okay. So let's look at some of the benefits, and there really are a number of benefits that you can achieve. But the first one here is, I think, very important. It's the seamless replacement of your existing systems and workflows. And I've alluded to this before. If you're using one of those backup applications and you have backup policies and backup procedures that you use today, you can continue to use those exact same policies and procedures that you're using today. You just drop in Tape Gateway. And I'm going to show you how we do that in this demonstration. And again, you start writing to virtual tapes as opposed to physical tapes. The second point, reduce maintenance costs. Again, you're eliminating that physical infrastructure, just as we saw in the Sony example. Your costs have become a lot more predictable, so it's easier to plan. You get all the security and durability that AWS affords, the military-grade encryption, the 11.9's durability. And this last point is also very, very important. I think it's accessibility, right? So you can access these virtual tapes. They're in the cloud. You can access them literally from anywhere in the world. And we had a recent example during the Hurricane Harvey that hit Houston. We had a customer of ours that was using Tape Gateway, storing virtual tapes, that called us in a panic. Their data center literally was underwater. Their tape library was underwater. And they called our support team, and our support team was able to spin up a new gateway in the cloud and help them to start restoring those tapes, those virtual tapes, immediately, that moment. So I think, again, accessibility is very, very important. All right, who's ready for a demo? Yeah. All right, so just a quick recap of how what we're gonna show here. I'm gonna show you in less than 10 minutes how we can remove the physical tape infrastructure and plug in Tape Gateway. So we're gonna create a new Tape Gateway. We're gonna create some virtual tapes at the click of a button. We're not gonna have to unwrap tapes and purchase tapes and go and run them and plug them into a tape library. We're gonna connect Tape Gateway to our backup application using iSCSI. We're gonna import those tapes into the backup application. We'll kick off a backup, and then we'll archive a tape. All right, so when you log on to Storage Gateway, you'll go to aws.amazon.com/storagegateway. You'll be presented with this Getting Started page. Oops. And you'll click the blue Get Started button. Then, you have those three flavors of Storage Gateway. You have File Gateway, Volume Gateway, and Tape Gateway. Again, in this example, we'll click Tape Gateway. Click Next, and then you select the host platform. Again, if you're deploying this on premises, you can click VMware or Hyper-V, and you can just click the button to download the image, and again, install that in that environment. In this example, what we'll do is we'll show you how to deploy it in EC2. We'll click EC2, and then we'll click Launch with AWS Marketplace. So we have Storage Gateway in the Marketplace. So that takes us to the Marketplace. Then the first thing you'll want to do is just select the region, and then click Continue. You can use one click or use manual launch. I like to use manual launch because we have a few more options to select. Again, select the region that you want to deploy this in. And that takes us to EC2. We'll just confirm the EC2 instance type, which in this case, the default is the M4 extra large. Then we want to add storage. Every storage gateway has a local cache. Tape Gateway also has an upload buffer. So we want to create those two disks. And again, whether you're deploying this on premises or in EC2, we want to add those two disks. And that's what we're doing here. The minimum recommended size of those disks is 150 gigabytes. So we'll add those two disks here. Then we'll configure the security groups. Again, we'll take the default here. Of course, you can edit the default, the security groups as you seem fit. But in this case, in this example, I'll just accept the defaults. We'll click Launch. We'll select our key pair so that we can log on to this machine later on if we need to. And then we'll click Launch Instance. So this is launching our Storage Gateway instance in EC2. There it is. That M4 extra large, we can see that it's running. And regardless of whether you're deploying Storage Gateway on premises, in a VM environment, or in EC2, what we want to do is take note of the IP address. The IP address, we'll take that, we'll copy that, and we'll go back to the Storage Gateway creation wizard, and we're going to plug in that IP address here. What this is going to do is it's going to associate my AWS account with that Storage Gateway. So we'll plug in the IP address here, and we'll click Connect to Gateway. And then we'll add a little bit of information about this gateway. We'll add the time zone. We'll give it a name. Every storage gateway deserves to have a name. So in this, we'll select reinvent here. And then we'll pick the backup application. Again, you can pick any one of these supported backup applications. I happen to be using Veeam's. And what that will do is it will set the appropriate media changer type. We'll click Activate Gateway, and we're almost home. The gateway is now active. It's looking for those 2 disks that I just created for the cache and the upload buffer. And there they are, those 250 gigabyte disks. We'll assign one as the upload buffer. We'll assign the other one as the cache. That other 10 gigabyte one is the default EC2 instance. We'll click Save and Continue. All right, and there's our gateway. Just like that, we have a new gateway. It's running, and there's 0 tapes. So let's go ahead and create some tapes. We'll click Create Tapes. We can select, again, at the click of a button, as I mentioned before, we'll create 5 tapes, and then we can select the capacity. I happen to be using LTO4 tapes before, so I'll go ahead and create some tapes that are 800 gigabytes each, just like LTO4 tapes, but you can create tapes that are 1.5 terabytes or 2.5 terabytes each. And important to note, you're not paying for that capacity. You're only paying for what you write. So it really doesn't matter. It's really more about maintaining the same backup workflows and policies that you had before. We'll give the tapes a barcode prefix. In this case, again, sticking with the reinvent theme. And we'll create some tapes. And just like that, we've created 5 tapes. They're creating, and now they're available. OK. So we're done with that. We've created Storage Gateway. We've created some tapes. Let's go to our backup application. Again, it's Veeam. I launched the iSCSI properties. I'm going to plug in the same IP address here of my Storage Gateway, and that will connect that Storage Gateway with this machine. We'll see all the tape drives. Storage Gateway will present 10 tape drives, and we'll connect each one of those individually, and then click OK. Now, Storage Gateway is connected. Now I can go into Veeam in my backup application, and I can see under Libraries, I see AWS Gateway VTL. So we're all connected here. So now what we can do is we can import those tapes. We'll click Import those tapes. We'll just confirm that action, because that's what Veeam is asking us to do. We'll click on Media. And there you go. We just imported those 5 tapes, and now we want to inventory those tapes to get a little bit more information about those tapes. We'll right-click, click Inventory Library. Again, confirm that action. And now we should see on those tapes, we can see now those tapes, the 800 gigabyte capacity for each one of those tapes. All right, so now that we have those tapes, let's go ahead and kick off a backup. We'll click Tape Job, and we'll click a backup. And Veeam will ask us for a few things here. It'll ask us to name the backup, and again, sticking with that reinvent theme, we'll give it a name. We'll then select our backup files. I have a backup job that I created earlier. We'll click on that. We'll click OK. Again, we'll create a full backup. You can choose whether you want to do a full backup or incremental backups. There's a couple of options here, whether or not you want to eject the tape after you're done or not. Every backup application is a little different here. You can schedule the job. But what we're going to do here is we're just going to kick that off automatically. And we'll run it right now. And I'm not going to make you wait here while that whole backup completes. We're going to actually fast forward a little bit. We can see that backup job is running. And almost done. OK, success. The tape job, that tape backup job is done. And we can see now that drive 1, the tape ending in 72, has now 700 gigabytes free. So we wrote approximately 100 gigabytes. So if you go back to Storage Gateway, let's click Refresh. We'll see that tape that ends in 72 has some data written to it, about 100 gigabytes. All right. Pretty easy, right? Let's go back now. Now we want to archive that tape. To archive a tape, you go to your backup application, we'll eject it from its tape drive, and then we'll export it. Some backup applications call it export, some call it eject. In this case, it's a little bit of both. We'll export that tape, and then once Storage Gateway gets that iSCSI command to eject the tape or export the tape, we move that tape to Glacier. So again, you're getting that lowest cost storage. So again, let me click refresh here, and that tape will disappear. Now it's in archive. So if I search for the reInvent barcode prefix, there's that tape, and we can see that it's been archived. Once a tape has been archived, it's good. You can leave it there forever, or you can retrieve it. You can click Actions, Retrieve, and now you can pick any gateway you want to retrieve that tape to. And that's what we were talking about before. So that tape now is in a retrieving status, and it'll take 3 to 5 hours for that tape to essentially thaw from Glacier. All right, so that's our demo. Thank you. So with that, I'm going to turn it over to Jesse, who's going to show us how you really do it.
Thank you, Peter.
Thanks.
All right, so I'm Jesse Martnick. I'm the Infrastructure Services Manager at Southern Oregon University. And I'm going to tell you a little bit about our process of doing what Peter just went through and kind of some of the background that also delves into a little bit of what David was talking about. So first, Southern Oregon University is a public liberal arts school in the Northwest. We serve just over 6,000 students and employ over 1,000 staff and faculty. So we are a state institution, which means that our funding comes from a combination of tuition from our students and from state budgets. And like many other state organizations and higher education institutions, we're increasingly feeling the pressure of our tight budgets and problems with state funding and higher education not getting the money that we need to thrive and to move into the modern technology world in some cases. So my team, which for infrastructure is myself, I split my time between the network and telecom side of infrastructure and the enterprise applications and storage side. And so the enterprise applications and storage side has 3 people and half of my time to manage 16,000 user accounts, 1,000 end user machines, multi-user machines, virtual machines in our vSphere cluster, and over 100 applications that are either enterprise applications or the applications we've deployed or applications we have to support. Even if they're vendor hosted, there's still some time and resources that come from my team to support those applications. So we don't have a lot of time to support all of the things we have, and so any savings that we can get from a human resource perspective is huge for us. So that was one of the driving factors in terms of the savings that we got moving to AWS was that we got a lot of time back, and a lot of the hassles that we had to deal with physical tapes were relieved. So in the beginning, like many, we had tape. So our process was someone would go in, cycled the tapes out of the tape drive, put it in a suitcase, the suitcase gets picked up, and they drive it off-site. So I think that's the process that many people do. That's kind of the standard. You need to get your tapes off-site. So that accomplished one of our goals as far as disaster recovery, which was to have our tapes off-site. But we were still in the business of maintaining the tapes, the tape libraries, the care and feeding of the tapes, and the tape libraries, as David mentioned. So it didn't really align with all of our goals in terms of supporting the university. Everything that we need to do, and the decisions we make in IT need to support the mission of our organization. And in higher education, that's not backups and making sure that computers are happy. It's really educating students and making sure that they're getting out the door with something useful, whether that's a degree or a certificate or being more ready to enter the job market and lead successful lives. So taking care of tape libraries didn't really meet any of those goals. We were wasting time fixing them. They would break down. We'd have to buy new ones, which, as I think Peter pointed out, there's a large hardware cost every few years if you need to move on to either a new LTO format or just because the hardware breaks. So we didn't want to keep maintaining tape libraries. We knew we wanted to get out of tape. And there was a couple things that we needed to look for in a new backup solution. So one was providing a reliable backup solution that would help meet the university's goals, which includes having reliable data. We need to be able to keep the university running even through disasters or inclement weather or any types of hardware failures on campus. So we needed something that would provide good disaster recovery was one. So as we already talked about, we got to get the tapes off site because this could happen. So there's fires in data centers. Your UPS can blow up. I've worked at a place where UPS blew up, and I know of another educational institution where they had UPS fires, 2 of them actually. So this could be your data center, so you need to get your tapes off site or get your data off site, right? You got to get it at least out of one place. And tapes did that for us. They were outside of the building. But we live in the Northwest, and so we're always afraid of the big earthquake that's going to happen. So sooner or later, in the next 500 years, supposedly, there's going to be a huge earthquake. It's going to completely destroy the West Coast, and the Northwest will be horribly impacted. So we're right there in Ashland, Oregon, and so we can pretty much expect that there's going to be a lot of infrastructure issues within our region. We might not be able to get to our offsite data if our local data is destroyed. This could be days or weeks before we have the ability to get to our data, and could be even longer before we can have new hardware shipped to us to actually get our data off of physical tapes. So that doesn't really help us. So our other options are we could colo, either self-managed or with a managed service provider, but we could get our data physically away from the Northwest. Or we could work with a cloud provider like AWS or any other cloud provider. We chose AWS. So when we're looking through what we wanted to pick for our replacement for tapes, we already have Veeam. So Peter's demonstration was very reminiscent of the things that I did going through and testing our process. So we already knew we wanted to stick with Veeam because we were happy with it. We wanted to keep our process simple. We were hoping to save money, and we wanted to make sure that we would be prepared for disaster recovery now and in the future. We wanted to make sure that we were planning ahead and not just kind of keeping our status quo. So the reason we chose AWS as our cloud provider was because it was really easy. I personally, when I want to evaluate a product, don't want to have to sign a contract or even necessarily talk to a vendor before I can try out their product. And it's not usually the case that that is possible, but with AWS it was. I downloaded the OVA file, I put it up in our VMware infrastructure on site, and within a few hours I had a virtual tape library or tape gateway up and running, and I could upload tapes. So we got to that point by performing some research, which was really just Googling what the cloud providers we could use with Veeam were. And we were attracted to AWS because of the low cost of Glacier. So that was really it. We knew we needed something that was low cost. We didn't have any extra money to make this change, so we needed something. We were going for what's the cheapest way we can get data in the cloud? What's going to be our lowest cost? And AWS had the prices for Glacier posted, so we knew that what we were getting into and we could start testing. So we did. We downloaded the OVA, got it going, and started working with it. So this is our environment, simplified a bit because we have more than one tape gateway, but this is really it. We've got our vSphere cluster and a few physical Windows servers. That's what we're backing up. We have user shares and department shares, and then a plethora of virtual servers, and then a few physical Windows servers, mostly for redundancy. So then all that is backed up on disk by Veeam and encrypted on disk on a NAS. And then we perform our tape backups through the gateway to S3. Luckily, Veeam has a box you can check to just export media after completion. And so we automatically export everything we back up right away. We don't keep anything in S3. You could, and then either script or manually work out a process for when you want to archive. But we archive everything right away. We just want it to go right to Glacier as soon as we put it in AWS to keep our costs as low as possible. So this is an approximation of our backup schedule. So like I said, we do on-disk backups of all of our servers and data that we're backing up. And so we keep those on disk for 30 days. And then throughout the month, we'll send a full backup of that month's data via the tape gateway up to AWS. So you can see some of the jobs will take a matter of hours, and some of them actually take a matter of days. For some of the jobs we have that are 9 to 12 terabytes, it'll take a few days for all of that to get up through the tape gateway into AWS. So we're able to run all of our jobs with 2 gateways, and we just have the jobs staggered. There's some overlap that you can't see here where we're running on both gateways, but we get everything up there within a month, and we have about 30 terabytes of data we upload every month. So then we retain our tapes in Glacier for 400 days, and then we delete them using a script. And we have some scripts also in place to automate the process of creating the tapes that Peter went through and importing those tapes into Veeam. Just some quick PowerShell scripts to import the tapes into Veeam, and I think a Python script to generate the tapes. So for tape deletion, as I said, we delete tapes older than 400 days. So this matches our physical tape retention policy of a year, and then gives us a little over a month just for funging the data a little, or just having just a little extra, because I liked the idea of getting just 1 month extra. So I'm going to go through just the script we have here. So this is a Python script. We just import Boto3. We're running this on site now, but it could be run through a Lambda function, which is something that we're going to work towards doing in the future, is moving that off of our site. So we go through here, we just set our variable for we want tapes older than 400 days. We then use the built-in client library in Boto3 to get our gateway. We retrieve all of the archive tapes we have, and then we convert the timestamp on all those tapes into UTC for the completion time of when the job finished on that tape. And then we have those in a list. And then for all of the tapes that match that criteria of being older than 400 days, we just go through and delete the tape. So this runs every day and just deletes all of our old tapes. And we've got, I included some code that we have. The describe tape archives function will page the tapes that you get out there. So we have a little marker to know that we just have a page, and if there's another page we should go get. And when we run out of those markers, we know that there's no more tapes, and we exit the loop. So this isn't the entire script. I'd be happy to make the script available to anyone who is interested, as well as the scripts we use to automate the tape import into Veeam, as well as the creation of tapes. So then once we have our tapes up there, tape recovery is pretty straightforward. It's very similar to just doing a tape recovery from an on-site library. So I go into Veeam, and I say I want to perform a recovery on this job. It'll tell me, well, you need to have this tape. So I'll have to go into AWS. I'll search in the gateway the same way that Peter did when he was showing you that the reInvent tape had been archived. So we'll go in there, search for the tape barcode that we got from Veeam, check the box, click Retrieve Tape, and then a few hours later, it'll be available in our gateway, and we can start the restore in Veeam. So from the Veeam perspective, it's really no different than having an on-site tape library. From the deployment, the archiving of tapes, and the retrieval of tapes, it's all just the same as if you had an on-site tape library. So the iSCSI initiator, like Peter showed you, I even scripted that when I was starting it, because I didn't want to have to go through and click and connect one every single time, because I probably went through 4 different tape gateways just playing with it and destroying it the first time. So it was really easy to implement, and that's the reason we stuck with it. So as far as what we would actually do in a disaster to recover, well, currently our default recovery option would be, well, if we need to get some data from 6 months ago because someone deleted something, would be just restore it back to our existing gateways, to our campus in Ashland, and restore through Veeam. And so that's kind of the process that I just showed you. I'd just go into Veeam and say, okay, recover this tape, and get through it. We also happen to have a second site in Medford, Oregon, 14 miles away. So if we had a physical site issue, like an exploding UPS or a fire or some sort of lockdown where we couldn't get into our data center, but we needed to restore some data, or we could drive down the road, set up a gateway, and just restore there. So that would also be a fairly minimal change in that process. Our data is stored in the US East Virginia location, so that really accomplished our disaster recovery goals by getting our data physically away from the Northwest. So The main national disaster that we wanted to be prepared for was an earthquake, and by moving our data into Northern Virginia, we've accomplished that. So all of our data right now is backed up on site for 30 days, and then after 30 days, we get a full backup shipped off to the East Coast, and there it stays for a year before it's deleted. And that costs us around $2,000 a month. So because we started deleting, which is actually very recent for us, it's actually gone down a little bit. It's a little under $2,000 a month right now. But that $2,000 a month saves us both in terms of the cost of having our tapes guarded off-site and paying a student worker or someone on my staff's time to feed the tapes and pull them out and organize them and make sure that we're getting the right tapes and sending the right tapes back, as well as the time that took away from my team, student workers that could be working on something else, to do those repairs, to just plan on the fact that we're going to need to spend hours every week replacing tapes and fixing the tape libraries. And so that's made a big difference to not worry about those things. Not just the time itself, but the peace of mind of not having to worry about our tape libraries breaking all the time. So that means that we can spend our time helping the university. So, as a university in an industry that is struggling, higher education, we have a need to be more competitive. And so to differentiate ourselves from other universities, we need to offer better services. We need to be more mobile friendly. We need to offer services to our students that really allow them to move through the educational experience better and with less challenges. And so for my team to do that, we need to be spending less time worrying about something like backups. So it has also improved our disaster recovery capabilities. So from a risk perspective, that's a big thing for the university, to be able to withstand a natural disaster as well as any type of localized disaster. And as an IT department, it makes us more confident in our ability to serve the university's mission, that we are providing services that help them accomplish their goals. And whoops, skip past that one. Yes, I would do it again. I've enjoyed the experience of moving to AWS for tape backups. We're excited to start some other new projects in the next few months. This project was in no small part, I think, the reason that we're now excited to move other parts of our infrastructure into AWS. We had a great experience with their customer engagement teams, as well as whenever I had any questions or wanted to ask their team about, how would we do this, or what if we want to do this. They've been very open to discussing options and really trying to answer whatever questions we have. So I think I'm handing this over to someone for the next steps.
I think just in terms of next steps, I think if you're thinking about using Tape Gateway and this sounds interesting, you can get started by, as I mentioned earlier, you can visit aws.amazon.com/storagegateway. You can drop by one of the demo booths. You can come see me or David or Jesse.